We have MEMS mirror, like you can see in here.
Yep.
They are array of very small MEMS mirrors. They scan up and down.
Yep. So in there's a load of MEMS mirrors.
Yeah.
Yep.
And we have, but these MEMS mirror only scan in the vertical direction. So we bring in another motor that can move the entire chip left and right, so they can provide horizontal scan.
Hello IPXers, Electronica 2024. We all know I love talking about alien technology. So this is Chin, this is Lei, from a company who are not a 90s boy band called InSync. So they're going to talk to us about LiDAR. And it doesn't get much better than having a model car on the demo and the video. Yes, that's cool. So we're going to talk about LiDAR. Tell us, if you didn't exist, the first question, if you didn't exist with this going on, how does LiDAR work today? And then tell us about what you do.
So for LiDAR, you shoot a laser to a faraway object, and the object will reflect back the laser, so you can measure the distance.
Yes.
However, if you just shoot one laser, you only get 1 point distance information. So you need an optical scanner so that your laser is scanned to all the different directions. You can sense the environment around you.
Yes.
So currently, there are a few options for optical scanner, and one most important optical scanner is called MEMS scanner. So basically, you make very, very small mirrors on a silicon chip, and that mirror can move around to scan the laser.
But they're tiny.
Yeah, but the current MEMS mirror scanner, since invention about 30 years ago, they always been very, very small.
Yeah. So just for the sensor, just for the people listening to the on this video, today, the MEMS scanner technology, how big are they today?
Usually, for most of the MEMS mirror previously invented, is about 1 millimeter square in area. Then later, because of the rise of LiDAR, people are trying to make bigger and bigger MEMS mirrors. Currently, the largest MEMS mirror you can find on the market is usually below 50 millimeters squared.
Right, 15 millimeters.
Squared.
Squared, yeah. Yep.
So the diameter is about like 7 or 8 millimeter.
Right. Yeah. So that's today's technology.
Yes.
So then you come along at InSync and you disrupt all of that.
Right.
So tell us what you do.
Yeah, we basically, the reason people cannot make the MEMS mirror larger is because once you make this very brittle silicon mirror large, they becomes very unreliable. It breaks very easily.
Yeah.
So instead of trying to make the MEMS mirror large, we made another breakthrough in this technology.
So you took a different direction, a different route.
Yes, we make many small MEMS mirrors and we synchronize them. That's why we are called InSync.
Oh, it's not because you're a boy band?
No.
I was sure it's because you're a boy band. Oh, you spoilt it now. Oh, no. Right, okay, go on. So, because you're syncing many MEMS mirrors together.
Right.
It's obvious, isn't it, when you actually think about it?
Yeah, so now each mirror is very small, so they still has excellent reliability, so you can use for automotive industry. But on the other hand, because many of them can synthesize a much larger aperture, then you get a very big improvement in performance in terms of LiDAR.
Right. So, and then what we talked about is, so just talk us through this. So in established technology, you'd have one mirror, one laser, and it would move, but because it's quite small, you would only have so much that you could take in. So what you've done is you've scaled it up. So this is actually the demo here. Yeah. Right. So you've got sending out the laser, and you're going to show how this demo works. But the point is, you've taken the established technology and you've scaled it up using your proprietary technology, so you can have a much bigger mirror.
Right.
That's essentially what's going on.
Yes.
Right. Excellent. So just talk us through what's going on with this really cool model car. Talk us through the demo.
Oh, the demo is quite simple. So we have MEMS mirror like you can see
Yep.
in here,
Yep.
they are an array of very small MEMS mirrors. They scan up and down.
Yep.
So,
So in there, there's a load of MEMS mirrors.
yeah.
Yep, yep.
And we have, but these MEMS mirror only scan in the vertical direction. So we bring in another motor that can move the entire chip
Yep.
left and right, so
Yep.
they can provide horizontal scan. The MEMS is like a very good at fast scanning. So the MEMS is scanning at 2 kilohertz,
Yep.
and the motor is scanning at 10 hertz.
Right.
So entirely you can.
So this is a frequency thing that you've also brought, so that because of the scale, you're able to do greater frequency. Is that what you're saying?
Yes, our MEMS mirror is very
Yeah.
small, so you can do very fast scanning.
Right, right.
Yeah.
So just toward now, because you've explained the technology that you're doing, let's just have the absolute game changer. Today, with LiDAR, you were telling me that you could probably reliably do scanning up to 50 meters. About 50 meters to 100 meters?
If you use small MEMS mirrors, you can probably reliably do detection around 50 to 100 meters.
Right.
Yeah.
And then using your technique,
Yeah.
how far can you go?
I think because we are in an array architecture, so we can scale the aperture as large as we want. So you can easily go beyond 200 meters, maybe up to 500 meters.
Up to 500 meters.
Yeah.
And that's because this whole idea of taking many MEMS and scaling them. So last question, I'm watching this and I'm used to using LiDAR either in automotive or in industrial applications, and I understand the whole concept of MEMS mirrors, I understand the concept of lasers, and then all of a sudden we meet you and you come along and go, hang on a minute, there's a completely different way of doing this. How do they evaluate you today? How do they get hold of this demo?
Oh, they just email us.
Or me?
Yeah.
Or me, okay. And then what do they get though? What do they? Is there an evaluation kit that you sell?
Yes.
Yes.
Yeah, something like this. We will send them something like this.
Send them something like that.
Without the car, of course.
Development kit.
Well, that's just silly without the car. Well, why would you send them it without the car? Right. So, but that is a development kit.
Yeah.
Also the demo.
Right.
The samples. Development kit and samples.
Right. So, and what sort of volumes would you need to be looking at in terms of you sending? How many of those do you send out? How many? Are there 50 of those available or 10 of those available?
We have about 20 available kits
Right.
that we can send
Right.
out to people.
Right. Okay. Very good.